Thank you, everybody. Good morning, good afternoon. Welcome to our next T3 session, which is for the API Connect version 5 Edge Gateway. So we have several members of the data power development team here today. Just to, it's basically the same process as we have been doing all week. So everybody's going to be muted. There'll be logical points where we'll have you go off mute by hitting *1 to ask questions if you have them. But with that, I'll go ahead and just turn it over to Ozzy, who will start us off with our presentation today. So thank you for joining.
All right, thank you, Michael. Good morning, everyone. Good afternoon and good evening, wherever you are. Today we're going to go through all the new policies that we added for the Data Power Gateway for V5 of API Connect. We have Steve Lin, Steve Groger, Ramon Spence, William De Palma, and Shufan will presenting today all the different policies and the different features that we added for API Connect version 5. Okay, so here's the agenda. We'll do a quick overview of what's new. Then we'll look at some of these you've seen if you attended the Micro Gateway one. So some of these will be common to both, but we'll go into a little detail as to what we did to implement them. And for the most part, they are the same, but we'll just mention it here as well. So we'll look at the if and throw and operation control flows, not quite policies, but they show up under the policy tab or the assembly flow. And then we'll go in through the gateway script, security overview, the rate limit. Again, not quite policies themselves, but just features of the YAML and the Swagger specification. And then we'll look at Invoke and Proxy. These are new policies: validate, JSON and XML, transform, redaction, custom, the conversions of JSON to XML, back and forth, and the map policy itself. Okay, so let me stop here. And William, I'll stop sharing, and we'll hand it over to you. Share your slide.
Sounds good, Ozzy. I believe I have them up already. Hello, guys and girls and ladies. This is William De Palma. Good morning, afternoon, or evening, depending where you are. Happy to be talking to you guys today. I'm going to be doing a little introduction on what is new in our version 5 of API Connect. You're going to find out that from enterprise offering, when we look into the Data Power Gateway, where our focus will be today, that's where our offering looks very similar to what API Management version 4 was. That's the part we're going to be looking into the gateway itself, hosted through the Data Power technology. So we'll start with a very simple overview and kind of on a topology view that if you are familiar with earlier versions of API management, that should be very familiar to you. We have a typical, three-tiered, diagram here with, on the left-hand side, your applications and mobile entities. Assets in systems of record on your third tier here through a set of gateway services in the middle tier. There's really nothing different from a topology view that what API management before was. We still have a set of gateway clusters. We have one or more gateway clusters. We're now calling them services in CMC, but they're the same thing, different name. And these gateways, they are hosted on physical or virtual data power appliances. They communicate with management services or the management nodes, like we used to call them, through the same communication needs, either through pulling configuration data through port 3 of the management services, or pushing analytics information on port 9443. And the management service, still, they configure and administer and manage the gateways through the XML management interface. So pretty much here, not much has changed from that perspective. The one thing that's worth mentioning here is that API Connect does require Data Power Firmware 7.5. And the reason for being that is that we wanted to have the latest and greatest and made some Data Power Firmware changes in order to provide the new set of capabilities that we're going to be talking to you today. We do expect that later on we're going to be providing some of these capabilities on a six-pack on the 7.2 service release, and in cases where we're finding a few where customers might not want to go to 7.5, there might be a possibility for being able to host them on 7.2, especially starting with 6-pack 5 and later. So that is pretty much giving you an initial high-level view of how these pieces continue to fit together, not many changes there. And I'll just pause briefly here for any questions regarding the firmware requirements, given that I've heard several of those for the past few weeks.
So yeah, William. So just to be clear, the firmware 7.5 it's what's recommended, and there is going to be a forthcoming fixed pack for 7.2 firmware that will be supported as well. Is that understanding correct? Did I get it?
That is correct. Yes.
Okay. When is that fixed pack for 7.2 expected?
I'm not 100% sure, but I would say any week now. It's really getting out of the way.
I thought it was already available. I thought it GA'd the same day that the actual product and 7.5 were made available.
Okay. Okay, I gotta check that out. All right, thanks. Any other questions for William at this point? Take *1 to take yourself off mute. Okay.
So we've got a bunch of slides, so let's keep going then. Thank you, Mike.
Yep, keep going.
Just a brief summary of, you're going to see that, what has changed. So I pretty much so far said nothing changed, but, there are a bunch of new things from a data power gateway perspective. One of the things you're going to see in API Connect, throughout the different presentations, and I just want to, mention it here, is that what you used to know as environment, now we're referring to a catalog. So you're going to hear in this and other presentations, catalog. And, just think about what used to be an environment before. You're going to hear a lot about the concept of products, and you're going to notice that plans have changed slightly. And I will just briefly introduce these two. So in version 4, you used to, to consolidate APIs onto plans that serves two purposes. They were a subscription access type of unit where you could get access to APIs through plans, but they were also a lifecycle unit where you could deploy, and publish retire plans on a plan-to-plan basis in version 4. In version 5, that has changed. We have reduced the plans to simply a unit of subscription, a unit of exposing access to APIs. And we have separated the concept of lifecycle, things that you can stage, publish, version, retire, co-publish, all that stuff into the products. And as you will find out when you start seeing the other presentations, is that now a product will have one or more plans. So, that effectively allows you to life cycle plans that are just different service levels over the same APIs all together versus having to treat them separately. So that was just a really quick touch on some of the terminology and some of the API Connect changes in this release. Another, very important change is you can see, our broader and extended support API or the Swagger specification in this release. You're going to see that we're going to be putting a lot of information through IBM Swagger extensions into an API document that allows you to take away from API management data stores your API definition completely, not just the interface, but the internals, including the assembly and the flows. That's a very important step in this version of the product. One other important aspect that Shufwan's going to cover later today is that we have changed the built-in authorization service for OAuth to be like hard-coded and kind of always present to becoming an API itself with the introduction of the concept of provider APIs. So like any other APIs, your authorization service can be defined using Swagger. You can customize their endpoints. You can customize their settings. We have, multiple scopes, which are long time awaited functionality. All that good stuff that we have been hearing on the field now in version 5. We have first-class support too. We're going to be going through a bunch of new out-of-box policies. And more important, we're going to start seeing some increased focus on gateway script as the language to extend gateway, rather than by introducing the gateway script policy and some context and functions that we will be sharing in the next slide. So moving on to this next page, and it's just really a X-ray picture, if you will, of what is running on our gateway when API Connect is installed and configured. You notice that if you have, adventured yourself into looking into recreating data power in version 4 and earlier releases, you will probably be very familiar to what those boxes are, or at least their existence there. We have a bunch of statically created objects in data power that are saved into its own application domain, and that we're depicting that with the in yellow. We have a couple multi-protocol gateways that we configured. One that's our API multiple gateway, and another one that we call it an internal one that does everything that we need. In the end goal is to provide what we call the API Connect framework that we are depicting here in this picture. Is the ability to dynamically be able to, proxy or be able to execute flows without interruption of service and completely driven by actions made in the API manager user interfaces, providing lifecycle support and analytics, collections, and all the good things that you're familiar that the product provides. There haven't been much changes on these objects themselves. However, in order to provide all the functions that we'll be talking about here and leveraging the latest from the firmware 7.5 release, we have rewritten the API Connect framework to feed itself from Swagger directly, and you're going to find the performance of syncing up with the management servers, and there's going to see a bunch of improvements on that area as well. The ability to do conditionals, error handling, and a few other things. I'm going to pause it briefly here, Mike, if there's any questions that before we kind of move forward and framework stuff.
I haven't seen any questions in chat unless I've missed something. If there's no questions, yeah, go ahead and carry on.
All right, carrying on. So what is new here on our assembly flow language? And if you're familiar with version 4, you used to be able to create a proxy or an assembly when defining an API. And we're finally, merging the two together. Anytime you define an API, you're really defining an assembly flow, even if that flow only has a proxy statement. So we're finally consolidating. There's one experience on defining an API. There's a very user-friendly new editor that you guys probably going to see more details, if not already, when you see the presentation from the UI folks. So there's a bunch of improvements there, starting from that consolidation. That whatever you do as you define flow, as I mentioned, gets serialized into the Swagger extensions that we have defined. So you're going to see under the code view that all the flow itself with, every policy that is going to be executed, they are clearly depicted in what sequence, what error handling, what type of conditionals, that kind of stuff will be very clear in source format. So you can, take it out of the product and add it externally if you want, use it, all that good stuff. So it's always clear and in the open in the API Managed Connected version 5. One main difference that I want to call out here is that now, as you look at a flow, you're going to see a flow that is close to the entire API, or, in contrast to how it was before, where you would define flows on a per operation basis. We believe that is, a step on the right direction, so you don't have to now code, very similar flows to different operations. So you just really code the one flow, and if you do need to take operation-specific actions, you can always enter some flows using the operation switch, capability in the flow that we're going to talk about very shortly. You're going to be able to line up your out-of-box policies to execute. Your security definitions defined in Swagger will be injected into that flow. Your user-authored policies as well can be referenced there. And we also are taking the assembly context variables that we have introduced in version 4 up to the next step, adding a bunch of new capabilities that we will be commenting very soon. Which we get to on the next slide, talking about context variables. And if you attended, the micro gateway presentation yesterday, you're going to find out that both gateways do share a bunch of those same variables, with the same semantics in both gateways. We started from the list of variables that we had in version 4. So I'm not calling them out, the entire list here. You can get to the latest and greatest from our knowledge center. But calling out for a few of the new ones that I think are quite interesting for you guys to see. First, you're going to have access to the original Swagger document through the API document variable in case there's a need for that in your flow. We are completing the request variable by provide first-class access to parameters, being query or being header parameters, to request the parameters. We had already request the header, so no changes there. We are adding request.body that provides you, synchronous access to a body, the original request body, in case that is provided with the request. If you, for example, are trying to access that body from a gateway script policy or through some other policy that does accept the body, it will be provided to you as a JavaScript object or a no-list DOM, depending on the format, or just a buffer, if none of the above. But we're going to provide you easy access to the body. We also are introducing the message set of properties, which are our ongoing payload as it flows through the to the assembly. So I'm assuming that we're running policies that do alter these information that came from the original request. You can always access the latest and greatest through the message dot set of variables, while the request dot always has the original as it arrives on the wire. The message dot can also be rewritten, so you can alter those you can remove headers, you can add and inject new ones, you can change the body, you can change the status, the HP status information in case you want to change when returning into the response. So the message dot is kind of your ongoing, changing payload as it flows through the different policies that are executing. You can also read and access these variables through dereferencing them with using a dollar parenthesis notation, or you can use that directly in your user policy, your user author policies by using our set and get variable functions available there. I'll just pause briefly. I might have gone in a little too quick in that. We do have a lot of content, but if you guys have any quick questions there on this topic, that might be a good time to take them.
One thing. William, you're coming through kind of soft. I don't know if you have a microphone that you're using. If you maybe just get it closer to your mouth or what have you. You're audible. It's just that you can improve the sound quality. It'd be great. One question that came up in the chat, and I know this might fork into a potentially deeper conversation, but with regards to performance, with version 4, I'm sure you're familiar with how things work with events being queued up and then posted to the management node via the WSM agent. From my conversations with Graham and the folks on the analytics team, that process hasn't changed. So is it safe to say that performance of the gateway, of the data power gateway in context within API Connect is more or less the same as it was with version 4?
I would expect it's more or less the same, but the WSM agent usually does not affect the performance of. They're different topics. Let me put it that way, Mike. The WS agent performance is actually completely orthogonal to latency and the request response servicing of APIs, because it's done on a separate push model that's separate from the client requests themselves. So you're right, that hasn't changed in V5, and we're going to have the same set of characteristics when sending them off band from requests and responses. From a perspective of performance in terms of throughput, we do not expect any changes yet. We're certainly running some tests right now, and we're not seeing anything that's that different. There is, one common through the years misconception or misexpectation is to expect that a very simple proxy on data power would perform, that the API manager would perform as well as a very simple, bump on the wire proxy in data power, which is the wrong expectation. Right? API management just adds a lot of processing to the proxies themselves by giving you the ability to do a lot of things in assembly, to automatically data collection and so on, right? All the characteristics. So I do expect that the same latency or the same capacity numbers that we have had in V4 are not changing for V5. We have made a lot of changes to use less XSLT processing and use more gateway script, but I don't expect that overall we're going to see major changes there, either better for better or for worse.
Okay, thanks. That was the only outstanding question I saw. So why don't you go ahead and press on, and then we can continue with questions later, so you can get done.
Okay. Sounds good. And I'll probably speak a little louder now. Just keep me honest if it's hard to hear. Okay, so moving into a couple of new, very important additions to the assembly flow, and these are also common on both gateway offerings or all the different offerings with either micro or data power gateway. We're adding operation switch, which I just mentioned, which is allowing you to execute a subflow very specific to an operation, and we are adding the if policy that allows you to do a subflow providing a JavaScript condition. So both both are new in this release, and they provide very much needed and important capabilities on conditionals. They are very simple at this point. So there are some, they don't have, for example, if it doesn't have an else clause, and operation switch does not have a default clause. But we do plan as new releases come to improve things like, expect to see something like a switch construct that allows you to do, instead of having to chain a bunch of ifs together, and some improvements that it should be expected later in the year. But, starting from what we could contain on this release, that's what you have in there. A couple of examples on following on. I'm not going to get into a lot of details because, they have been gone through some details on yesterday's presentation. Same thing applies to the data power gateway. You can use operation switch. You can match, as shown in this example on, a get, an operation that's a get on / account and run a subflow. In this case, it's just an invoke flow. Or you can match on a post, and you can then invoke something else in case you're either reading or writing to that account. If you think that on a broader scope, imagine that you have a bigger flow here that's for the entire APIs, your accounts APIs in this case, where you might have a bunch of common things, for example, audit activity log or redaction or validation or a few other things that you might want to do for all operations. But when you need to do some specific operation-specific, subflow, you can use operation switch to trigger or to fork into those different subflows. And later on, an example of if, again, conditions are a JavaScript expression. You can do reference, like you can see here, an example, one of our assembly variables, request a content type. But, it's pretty much, we're evaluating JavaScript at this point. If it evaluates to true, we're going to execute a subflow. Moving to the topic of error handling, we also introduced a couple of new, language constructs, like we have operation switch and if. We have the ability to add catch blocks into your flow. So in case there is a failure during the flow execution, you can catch that failure and run a termination subflow. So if you do not use catch blocks, you're going to get the similar behavior that you got on version 4, where an error would abort and interrupt the flow. But now with the catch block, you can catch that and be able to continue running a different flow. You can catch on error labels. There's pretty much, there's strings. We have a few ones that are predefined in our out-of-box policies. I'm showing you some examples here, like connection error or JavaScript error. We have our generic policy failure in case a policy does not define anything specific that we call runtime error. But you can define your own if you're writing your own policy, or if you're using the throw policy itself, where you can just define your own errors and be able to catch on them at a later point. A very simple example of a throw would be you're doing some conditional, you're checking if some information on the request is not what you want it to be, you can just throw an error and then catch it, and you have some error handling logic to trigger from that. So that is primarily what this is. Quick example here, showing a invoke. It's a typical proxy here where all it does is take the request in and calling a backend. And in case there are errors, you have a couple of catch blocks to just show a couple of different things you can do. You can have several entries with errors, so you can catch on one error specifically or a list of them. In this case, I'm catching only for connection errors. I could have additional errors entries in my catch block. So if I want to have different subflows depending on each error, I can have that. Or you can define the keyword default instead of errors, which means in case of none of the errors that you have declared match, it's your last resort. So it pretty much will run in case of any other errors that you haven't specified there. So here, a pretty dull example, but showing this capability. We're going to invoke if there's an error connecting to that server. In other words, it throws the connection error. We'll catch that, and then we'll set a return code, a status code on HTTP response of 400. In case it's not a connection error and something else, it would return a 500 error. It's probably something that was not expected to happen. So very, very simple case here. But remember that you can run any subflow, so you could do other things in case of an error. You can run other policies. You can do a lot more work in setting up your error messages and things of the sort. Any questions at this point for conditionals or error handling?
William, why don't you go ahead and just finish up the rest of your slides, and we'll open up for questions then.
Fantastic. So talking about, start moving to the new policies that we have introduced into this release. And, as I mentioned, you're going to see a lot more, focus on gateway script internally and externally. And one of our first class policies that we're adding this release is the gateway script policy. It allows you direct access to gateway script in data power. If you were on yesterday's presentation, you've seen that the micro gateway has a JavaScript policy, and there are different policies. The JavaScript policy on the micro gateway allows you to run JavaScript on the micro gateway and is not recognized by the data power gateway. It has its own constraints that they got into, they were explained yesterday, but focusing on the gateway script policy, it allows you to run gateway scripts in data power. It does not run on the micro gateway. One common question is, what is the difference between the two? And, usually the way I define is that, gateway script is JavaScript plus the data power modules and extensions. So you can run JavaScript code. That JavaScript code is embedded in your Swagger document, so you can easily see what you have added in source code. And you can add data, you can bring in data power modules or extensions. You can do crypto things. You can do all the different modules that data power defines. You can also, and when you run that policy, we are automatically loading the API connects module using an API-M an API-M variable in that session. So you can, through that, you can, do things like reading and writing contexts, payload or variables, and a few other things that are available in that module. And, there has been some discussion prior to release, but I'm happy to say that we are going to support gateway script policy also in the Bluemix offering. So it's not going to be an on-premise only, but I will, it's not going to be the exact same support. We're going to probably lock down the Bluemix support, so just we can protect against some possible vulnerabilities of somebody trying to, write scripts that could compromise the operation of other tenants in Bluemix. So I'm not going to get into those details of what those restrictions are because we're still working on that. And my final slide is just really a quick example. You have on the left-hand side or how you see that in our new UI. You can, bring in that policy instance, and it will just provide you a nice editor that does some that allows you to enter the JavaScript snippets there. And on the right-hand side is when I switch into source code, you can see our Swagger extensions showing you the flow that I just added with the gateway script policy embedded in the Swagger there. And that is the end of this piece of the presentation. So Mike, any questions before I hand it over back to Ozzy?
Yeah, so we got a couple of questions here that I think are good that we should address here. So first question is, so in the operation switch examples, they had a username and password specified in the clear. Is there an alternative to specifying the credentials versus doing it in the clear for operation switch?
I think you had an invoke with the user and the password, William.
Yeah. So right now the answer is no. So they are specifying the clear in the source. However, the question is who does have access to the source, right? So well, let me answer it again. There are some alternatives. So, but if you set them in the source, they are set in clear, right? But you can also set them, and probably will be the most common case. You can set them as API properties like you do today in V4, and you can add as there are catalog or environment specific, and you can refer those to using context variables in there. So all you see in the Swagger is the context variable, right? That would allow you to be portable across catalogs, but also it would hide because you have to enter that into into the catalog view, catalog specific properties, which have a different user experience, and it will not be on the Swagger itself. Does that make sense?
Yep. Were there any questions, Michael? Or
Yeah, sorry, we got dropped here in the conference room that I'm presenting from. Apologies. So was the one question about the users and passwords in the clear answered already?
Yes.
Okay. Second question from the chat was, will we have a migration path to migrate from micro gateway to data power in case of customers who decide to start with the essentials and professional and then upgrade it to enterprise?
I don't know. To be honest, I don't know. We do have a lot of common policies, so in each case you probably don't need to migrate, but things that are gateway specific, I don't know of any plans of migrating. So for example, if you use a JavaScript policy, have it auto-migrated to gateway script policy, I'm not aware of any plans on that area.
Okay. Last question I see in the chat is, how can I manage the properties of gateway script? Is it possible to use properties defined at the API level in the properties section?
Yes. So that's part of what my answer was on for the user and password in the clear, is that you can define your API properties and you can access them through context variable. There's API.properties.property name, and same way you can define username and password. You can define other things that are environment or catalog specific, and be able to access them through gateway scripts.
Okay. All right, that was all in the chat. We got a couple minutes for any additional questions. Star one to take yourself off mute, please. Going once. Okay. Thanks, William. Ozzy, you can go ahead and carry on.
All right, thanks. I'll try to run quickly through my slides, because we have a whole bunch of slides still to go through, as you can see. So we're running a little behind, I think. So this I'm going to talk about next is a security overview, essentially our support for the Swagger specification 2.0 as relates to security of an API. What I've shown you on the slide, and mainly it's about the and and the or scenario, if you will, and also security then per specific API. So what I've shown here is the little screenshot of the security section, and you have option 1 and option 2. And what this means is you can do option 1 or option 2. And so for option 1, you can either when the request comes in, you will take either the API client secret and client ID, or we'll also take the basic URL. If one of these two succeeds in the request, we'll let it through. The appliance will let it through to process the rest of the flow. Okay. Here's the the source version of it. As you can see down there on the lines 40 through 43, how you specify it in Swagger. You may also override what I call the API security, the global ones, for a specific path and method. And that's what I've done here. I've said don't use the API security definition at the top level, but rather for this specific URL and operation, use only basic URL, and only that one has to match. If they give you the client ID or anything else, then reject it for this operation only. Similarly, you can say for this particular API then, or an operation rather, do not use any. And so you override by using security with a little, the little empty bracket there. That means no security on this particular one. The global ones and the other ones may have their own, or they use the global ones. But when you see this, it means you're not going to have any security on this particular API. Or by default, any APIs that you add will get the global security definitions. Oops, let me go back a second. For the OR scenario, also the OR and the AND also works at the API level. The ORs in the web GUI will have a little plus here. I'm sorry, the global one has a little plus. For the API ones, you have to manually add the lines, similar to lines 40 to 43 for the specific API ones, like I shown here. Okay, let me go to the next one. Next is rate limit. So rate limit is just basically the same as before. I'm just going to go a quick screenshot of how it works and what it does. A product itself defines the plans or contains the plans. Then within the plan, you add the APIs that are under that plan, if you will. Okay. So here, for example, I have a plan, and I said, okay, this plan applies to these APIs that I've, the HTTP bin get and the stock quotes APIs down here, and each one of those gets 10 requests in a minute. You can have, I believe, seconds, minutes, days, and weeks, I believe is the intervals. This is the same as it was in previous versions. However, you may, by clicking the little gear wheel down there, or the little dot, you may then override the overall plans for a specific API or path and operation as well. And that's what you see here. So in this case, they're still in the plan, but each of these guys have their own individual rate limits that have to be enforced. Okay, so at this point, let me see, what's this? This is Steve, right? Okay, so that's any questions on security and rate limit?
Didn't see any in the chat, so.
Okay, cool. Yeah, it was a quick one.
I see one here. Can you set a global rate limit versus a rate limit?
For the whole appliance, I don't believe that's the case. I think the limit, the highest you can go is for a plan. You mean like on the appliance itself, Matthew? Like
yeah, star one to take us.
Like a catalog rate limit?
Yeah, so in other words, my mobile device. So I guess that'd be at the.
No, I don't believe so. Like, to you particularly, mean, or just like the API is a product. Oh, okay. A product has plans. No, but I don't believe so. Each of them. I don't think we did that in version 4, so I don't think we do that in version 5.
Not,
Yeah, there's no changes from support we had in version 4.
Okay, I see another question. So yeah, Joel, I kind of glanced over the security one. So what I showed you was the security elements themselves. The security definitions are declared elsewhere within the Swagger, though. So the spec has the API key, HTTP URLs, the basic, and the OAuth security options. I did not go through those. I was mainly trying to do the logic and the Swagger specification support for this one.
Yeah, there was a point made about competitors supporting multiple rate limit types. It flashed up quickly. Ulrich had mentioned that our competitors support multiple rate limit types per API. Here, let me see if I can see the whole question.
So on a single API, you're saying you have multiple, like either per minute or per day, to be in parallel. Do we have plans for this? I don't know if we have any plans for that, Ulrich, at the moment. So I'm going to say no at the moment. Right now it's one per, you only get one rate limit per API, I guess. I wouldn't know how
I believe we have had a request for enhancement on the system for that for a while. It hasn't raised up high enough yet to get implemented.
Okay.
All right. So it looks like Steve started sharing, so I will hand it over to you, Steve.
Yep.
Thank you.
Okay, thanks, Ozzy. So yeah, my name's Steve Groger. I'm going to cover the 4 or 5 of the policies we have within API Connect for the Data Power Gateway. So I'm going to present the policies you see there. I'm just going to go quickly for each policy, just go over a quick overview, usage, discuss some of the policy properties, any errors, and just give you a link to the documentation in the Knowledge Center for each of those. You've probably all seen this before. This is just a slide showing you the assembly view in the API Manager user interface with the list of the policies down the side and some of the operation switches and other things which William showed you earlier. So kicking off with Invoke and Proxy, which both include the response caching. So for those of you that know about APIM version 4, we had a proxy policy in there, and we had several other HTTP operation policies that you could put into your assemblies, like the HTTP GET and HTTP PUT and things like that. We've combined, we've left the proxy policy as it is, but there's a lot more properties on that policy, and we've combined all of the HTTP GETs and PUTs and POSTs into one Invoke policy, and you just choose the operation as part of that. Now these these policies are used within an API to call backend services, and I'm discussing them both together because they're very similar in the properties they use, and which we'll cover in a minute. And both of these policies can be used on both a REST and a SOAP API. So looking at Invoke, with the Invoke policy, you can call an existing service from within the operation within the assembly. And the policy can be used with sort of JSON or XML data. I think it does also retrieve text data and binary data, but some of the other policies won't be able to utilize that further on in the flow. The Invoke policy can be used multiple times within your assembly, so you can call an Invoke to go to one backend service, pull the data in, and then a bit later on call another service, another Invoke to get some more data from somewhere else, and then maybe combine all of that data into the response back to the user. The proxy, again, is very similar to the proxy that we had in version 4. It does allow you to call another API within your operation, especially if you want to call large payloads, because it uses the service routing URL mechanism within Data Power, whereas the Invoke uses a URL open. So the proxy provides more functionality in getting larger payloads and things back. The only proviso we have is that the proxy should be the last request policy defined in the branch of assembly, because it does call the service routing URL, and it goes off and does different processing on the gateway side of things. You can have more than one proxy policy on your assembly, but they need to be mutually exclusive or contained in mutually exclusive branches of the assembly. So you can have multiple proxies in separate branches. So looking at some of the policy properties of the policies. First off, we have the invoke URL. If you look at the slide here, the text at the beginning of each of those slides is what you see in the user interface. The bit in brackets is actually the string that is used within the Swagger, and then the type at the end is just the type of the variable of the property. So here we have the invoke URL, which in the Swagger is called target URL, and it is the URL that you want to use to actually call the backend service. Now, William showed you and mentioned about the different context variables we have and can be used, and the way you can use those. And within your target URL, you can also use those within your target URL. So for the example there, the API path that's defined is like /test/friend/ open bracket friend ID, question mark location ID. Then you can use some of those parameters in your actual target URL to actually go off and extract some of those from the request coming in into the request that into the URL that you're going to actually send to the back end. Now, out of all of the properties within the invoke, the only one that is mandatory is this invoke URL, the target URL. All the rest are optional and have default values if you don't set them. As I mentioned earlier, the invoke now takes, instead of having separate policies for the get, the put, the post, and things like that, we have an HTTP method or a verb which you specify to actually define what type of call you're going to do to your backend system. You have the same for both proxy and invoke, because with proxy we're actually now saying you can actually override the initial method that the API was being called on when you call your proxy. Before, in version 4, if you did a post on the API operation, the proxy would also do a post. So within the v5, you can actually override that by using the verb or the HTTP method to do that. If you want to keep it the same, then there's the option that you use keep, and that will maintain the verb that is being used as part of the API. So the valid values for these are get, put, post, delete, patch options, and for proxy you've got keep. Now the default, if you don't supply this as part of the Swagger definition or through the UI, is for an invoke will be get, and for proxy will be keep. Several other properties that are part of the both the invoke and the proxy are the TLS profile name, which is the which you use to actually sort of define the secure transmission of the data. It's the same as the micro gateway definition that you may have seen yesterday when that was presented. There's also a timeout, an integer timeout, which you use to wait for the reply back from the endpoints, and then when that times out, if that times out, you get an error back. There's also, to allow you to provide some HTTP basic authentication within your invoke, there are two properties, one called username and one called password, which you can specify in there, and that will generate an authorization header, which is put onto the headers that are then going to be called or used when calling the backend service. And as William said earlier, these are the bits that are actually, the password will be in the open, but you can use the mechanism that William mentioned to override that and secure that. The other thing we have is compression. So within whether you want your response compressed or not, you can select a compression Boolean variable to say, yes, I want my responses to be, for my request to be compressed. And that uses the basic data power compression algorithm to compress those. Now, lastly, for both the proxy and invoke, we've added some caching properties that can be used to define how the response data is cached within data power. The invoke, all the properties you've seen so far are common across the data power gateway and the micro gateway. The cache response data you see here is I think is specific only to the data power gateway. So we have three properties. The first of them is cache response or cache type, which defines how you want the caching to be performed. And there are three options for this. One is protocol, and that basically says use the actual caching behavior that's defined within the headers on the request and the response for that invoke or that proxy. No cache basically specifies that you don't want to cache this no matter what's in the headers. Now there is a proviso here in the fact that if this document or the response was already cached and is already in the cache within the data power appliance, the document will be retrieved from the cache. But if it wasn't there, it wouldn't put it in the cache if you've got the no cache. So it's not saying don't get it from the cache. It's saying don't cache this if it's not already there. That confused a couple of people when they were doing some testing, so I just thought I'd raise that as a point here. And then lastly, the third option that you have here is the time to live, when you specify the time in seconds that you want the document to remain in the cache, and that is specified on the time to live property. And the default for this value is protocol. Now the last two, we just mentioned the time to live value, which is an integer in the range of 5 to that huge number in seconds, and the default value is 900. And the cache key is it specifies a unique identifier that is used in data power to actually identify the document that's going to be cached, and it can be used if you've got multiple requests to the same URL, but you want different caching behavior put onto it. You can actually specify a different cache key for each of those requests, and you should be able to get different caching behavior based on that. So those last three properties are all to do with caching. Now the last property on the invoke and the proxy policies is the response object variable. Now if you set a response object variable, the data you get back from as the response from your invoke or your proxy will be stored in this variable as the body, the headers, and the status message. It will not be stored on the flow or the wire, and so is then usable for to be retrieved by other policies in the flow. So you can actually go and say, well, I want to do 3 invokes and store each of those bits of the responses in different context variables, and then use all of those context variables in a map somewhere to then map the data to either return to the caller or off to another invoke to use data somewhere else. So that, I think, let me just go on. So this is just an example of the invoke from the Swagger. So you can see down at the bottom there, it highlighted is the invoke. It's got the timeout, it's got a verb of get, it's got cache response as protocol, which is the default. It's got the target URL, and it's using an output variable called myOutputVar to store all of the responses from that variable. As William mentioned earlier, the new policies can actually throw some errors. So one of the errors that the invoke policy throws is the connection error, and these can be caught in the flow assembly. The proxy policy doesn't throw any exceptions other than the general runtime exception, which can be caught as well. And there's a little bit of documentation pointing to the knowledge center there on both of those policies. Before I move on to the next policy, are there any questions?
I didn't see any in chat that were still outstanding. Did you want to finish and then maybe allow some time for questions at the end?
Yeah, sure. I'll carry on then. So the next policy is the validate policy. Now the validate policy is new in version 5 and is used to validate the request or the response of of data coming into the API, or the response from an invoke or a proxy and the data going back to the client. There's two notes here that the schema defined is a JSON schema, and it has some additional Swagger additions into that. Specifically, the Swagger extensions are used to correctly validate against XML data. So you generate one JSON schema that can be used to validate JSON content or XML content. So the validate policy can be positioned at various places within the assembly flow. So if you want to validate the original input coming into the into the API, you put the policy at the beginning of the flow, and you specify that you want to validate the request. If you want to validate an intermediary response, it was returned from an invoke, then you put it after the invoke, and put it at the end of the flow if you want to validate the data that's going to go back to the caller. Skip that bit. I'll cover that later in a minute. So there's really one property for this policy, and that is just the definition. And the definition has three values that it can be. One is request, which, as I mentioned earlier, is used to determine where to get the policy from, the schema from when you're going to validate possibly the request. So within your Swagger, you may have a schema defined for the request of the API, and specifying this to request will actually go and retrieve the schema from that location. If you set it to response and you want to respond to the validate the response going back to the caller, then or from an API, then you can actually specify the response, and it will go and look in the Swagger for the different sort of status codes. So if you get a 200 back, you may want to have a different schema to use than a 404 or a different HTTP status code. So you can specify different schemas for the different status codes. Or if you want to fix a schema, the validation to use a specific schema, the schema is created and stored in the definition section of the Swagger, and then you just specify #/definition/definition name, and it will utilize that specific schema to do the validation against. And as this is the only property, it is a mandatory property. So I'm sorry for the small writing on the right-hand side, but hopefully you can see that. So this is just to show you the different locations you can define the schema. So I mentioned earlier about the schema for the request. So here you see we've got a path for a basic, and then down under the parameters, it's mentioning schema, and then we're actually referencing, you can reference the actual schema in the definitions or from that position. So we're actually saying we're going to map this against the account details schema. And then for the responses, you can see here we've got a response, a 200 response that has a schema defined for it. We also have a default response code that has a schema defined for it. And if you specify response as your definition type, then it will actually go and pull one of these out to use to do the validation. So this is just an example of a schema definition. You can see it's actually defined in YAML because it's part of the schema, but it is really a JSON schema object that's defining it. Here it's just some friends input. It's going to have various properties. One's an ID that's of type integer. Another one's a name, which is a string that has a maximum length of 15. Then you have an age, which is an integer, a gender, which is an enumeration, can be either male or female, and then you have a friends array type, which can have a minimum of 1 items, maximum of 5, and so on. So you can actually define your actual schema for your data here, and it has your required properties, whether it's ID, age, name, gender, or friends, things like that. So you can define all of that as part of your schema. And that schema that I just showed, because it has, I'll go back, and I'll cover it later, but there's a couple of XML elements in here. You might see just on the left-hand side under the description, there's an XML that says name person, and on the right under the friends bit to do with the array, you have an XML name friends and an XML wrapped true. That's just so that we can convert this schema into XSD so that it can validate against a XML document as well as a JSON document. So that schema can validate the JSON on the left as well as the XML on the right. Now, the reason we had to provide an XML name person is because you can't have just ID, name, age, gender, friends as part of an XML document. The XML document has to have a root element, whereas the JSON document, basically the object is the root element. So you have to define what the root element is for your XML, and this is just calling it person. So this is just going over what I've just stated. So the XML document needs to have a root element, and you define it here. So this is just saying if you're going to use this to validate against an XML document, then we're going to create a root element called person to wrap everything in. And then the last is with an array of objects in JSON, you just have a JSON array and just put the data in it. With this, you have to define what the name of the actual top-level element is, and then the name of the individual elements underneath it. So we're specifying here that the top-level element is called friends, and it's going to be wrapped. So basically, it's just going to put that element around all of the friend elements inside it. So if we just quickly go back, I can show you. So here we've got the friends element, and then we've got a friend, whereas on JSON, it just has friends with Jim, Jimmy, and Bill. So you have to put the other elements in. And so that those parts of the XML schema, or the schema here with the XML elements, are used to generate that. So this was just showing, this 4 sections here, just showing how you would validate against various schema definitions. So here there's just a validate option within the Swagger that's going to use a specific schema to validate against. So it's going to use the definitions friends. On the right-hand side at the top, we're actually validating against the specific request. So it's going to get the request schema for that and validate against that. And then bottom left, we have it's validating again after an invoke. We're doing a validate. It's validating against a specific schema, or here we're validating after an invoke. Oh, I didn't put the invoke in. Against the response. So that's just going to use the different parts of the schema, or the schemas defined in different parts of the Swagger to actually do the validation against. Again, this policy can throw the validation error. So if you get a validation error, it will throw that and give you the information about why why you got the validation failed, and there's that part of the documentation is listed there to find more information about the schema, about the policy. Any questions on that?
No, go ahead and carry on. We'll do a catch-all here at the end.
Sure. One of the other policies is new, very similar to the gateway script policy that William mentioned earlier, and that is the XSLT policy. The XSLT policy allows you to inline some XSLT and get that called as part of your flow, of your API. It can be attached to both the REST and SOAP. The only thing is this policy is only really usable against XML data and can only generate XML output. So if you've got any other type of data, then you should really use the gateway script policy to actually process that. The XSLT is mainly for use with XML data. There are two two properties for this. One is is an input property, which defines whether you're going to use the current context payload. So whatever's on the wire is going to be used be passed into that XSLT to be processed, and that's just a Boolean that's set to true or false. So if it's true, then it will use the data that's on the wire, the payload that's on the wire. If it's set to false, then it doesn't pass anything into the XSLT at all. And then the source is just the XSLT source that's going to be used for that policy. The default for the first one is false, and the only property that is mandatory is the source field. So here's just two examples again of the Swagger. So here we have on the left-hand side we have an XSLT that's not going to be using any input. So it's just a very simple thing that's just going to print out "Hello World" or put "Hello World" as part of the content. And then on the right-hand side we have something that sets the input true, and then it's going to actually be passed in the data that's on the wire as part of the payload into this, and it will do some processing based on that content. Again, errors that can be thrown as the transform error, and there's a link to the documentation there. One of the other things we did, this was available in version 4, is Redact. We did modify it slightly to work with the new Swagger definitions of the policies. So you'll see it's slightly different in the way you define some of the objects. So this is the Redact policy allows you to redact either the request, the response, or the logs to remove specific data, sensitive data that you may not want put into those things. So, for example, you may not want credit card details displayed in logs and things, so you could use Redact for that. So within the properties of the policy, there's an actions object, which is an array, and it's just an array of all of the actions you can do. And then within that array, you have some properties. One is the action, which is to define whether you're going to remove the objects completely or you're going to redact it, which basically obfuscates it with asterisks everywhere where it matches that data. You have a from variable, a property, which is an enumeration, which allows you to select request, response, logs, or all. So if you just want to do things from the response data, then you can just put response. If you want to do it from all of them, you can put all, and you can choose between all of those, and the default is all. And then you have the path, which is the XPath expression, which is going to be used to map into the request or the response data or the logs to find the elements of data that you need to either remove or to obfuscate. Now, the XPath expressions will be different based on whether your content is XML or JSON, because within Data Power uses JSON-X to define or to store some JSON data. So you have to be able to write your XPath as though you're mapping into a JSON-X document rather than just a basic JSON document or a basic XML document. So there are lots of instructions within the Knowledge Center on the Redact policy on the differences that you'd need to do for that. And here's just a simple example. In the middle is the Redact policy that I'm going to have. So it's going to do a redact from everything, and it's just going to redact it's just going to go and look for / street address. So on the right-hand side, sorry, the left-hand side, is some input data that's being passed into the Redact policy. The Redact policy is going to say we're going to get rid of everything that's got street address, or we're going to obfuscate it. And on the right-hand side, you can see that we've obfuscated everything to do with street address. So it's very simple policy. This does throw a redaction error, and again, a link to the information of the Knowledge Center there. especially if you need to know about the XPath that you need to do, differences between what you need to set up for XML and JSON content to do that. And the last one I'm going to cover is the custom policies. Now, the custom policies are very similar, or new enough very similar to what we provided in version 4, with one or two slight differences. So the custom policies are used to just implement your own logic for putting things. So if we don't have an out-of-the-box policy that provides the support you actually want, you can actually go and write your own policy, load that into the catalog that you're using, and then use that within your assembly flows for your APIs. Now, the only difference is in the creation of the policies. In version 4, the definition of the policy was you use JSON to define the properties and the definition of the policy. Now it's got to be in YAML format, and because we now support 2 gateways, and the implementation for the different gateways, the data power gateway and the micro gateway, are different, we need to be able to define which gateway the policies are available for. So within the policy definition, there is a new gateways element that you need to define, and for data power, you need to specify a data power gateway entry for your gateways element. I've described a lot of information in the slides here about how to create your custom policy and package it and things, but as this is very similar to what was in version 4, I've put the data in here, but I'm not going to go into it in too much detail because I know we're running out of time as well. So basically, you just need to be able to define and describe your policy, which is in the YAML format that I mentioned earlier. Then you need to go and create the implementation by using data power itself and going through creating your XSLTs and other bits and pieces there, and then exporting that information, packaging it in a zip file along with the YAML definition, and then you use that to import into API Connect. So this is just providing some information about the content of the YAML file, and the only real difference that we have is the gateways that I mentioned earlier. So I'm going to quickly flick over some of these. This is just an example of the YAML file. So it's defining a custom context policy that takes a couple of properties as part of the policy, and it's a data power gateway policy. The implementation, you need to use the data power tooling and the concepts there to create your policy and then export the data, and this is just going through some of that. I'll flick through some of this because I don't think, unless anybody's got some questions, then I'll flick through it, and if they have questions, I can come back to it. And lastly, just package and import your policy. So the zip you've created, you need to create a zip file that contains the following folder structure. So you have your policy YAML file, and then the zip file that you actually exported from data power containing all of your XSLTs and your configuration there needs to go into the implementation directory within the zip file, and then all of that is packaged up into a zip, and that's what's loaded into your API Connect catalog. And the policies need to be loaded into every catalog that's going to be using your custom policy. So it's not a load once into API Connect and then use. So if you've got an API that uses it in 3 different catalogs, it has to be loaded into each catalog. There's no specific errors thrown from custom policies when they're executed. It's dependent on how you write the policies, and there's the information there on the Knowledge Center link to get to how everything you need to know about creating a custom policy. I think that's it for me. Yep.
All right.
Any questions?
Yeah, good stuff, Steve. So a lot of information there. So let's go and open up the line for a couple questions here. I know in chat there's been a lot of things being handled by William and others. Thank you. But star 1 and take yourself off mute before we carry on. Any questions here?
I've read they've done a very good
Yeah,
job.
so there's been a number of questions about the slides. So, guys, I'm going to ask you to be patient with this. Slides from yesterday will be posted later as well as with these. So we have a team here building the POT, and we're doing these T3s here at the same time. So if things aren't up immediately, I just ask you to be patient. They will be there within one working day after these sessions are done. So I appreciate your patience with that. Okay. All right. Who's next?
I believe Steve Lynn is next.
Okay. One moment here. Let me get off of mute.
Yeah, Steve, you're not quite audible. I don't know if you're far from your mic or.
I think you went on mute, Steve. I could hear you before. No, I don't hear you.
Yeah, it was just soft.
Okay, can you hear me now?
That's much better.
Okay.
Thank you, Steve.
All right. Okay, let me see if I can get to my starting slide. Okay, so hello everyone. We're going to be talking here in the next segment here about three policies. We have the XML to JSON policy, the alternate JSON to XML policy. We'll talk about those, show some examples, talk about some potential future things that we're considering. And then we're going to talk about MAP. So, MAP is quite a powerful policy. There's a lot of things you can do. There's a few things that you can't. And we'll just show some screenshots of the UI interaction, what the actual Swagger language looks like, and plenty of examples, and again, some additional potential enhancements that we're considering short term. So getting into the XML to JSON, the actual implementation is actually a lot more powerful than we're currently making available. At this point, we're only allowing Badgerfish output from XML to JSON. I referenced the Badgerfish site to just give you the general rules of the conversion. The actual policy itself, where you see a lot of these options here, there are potentially some other options that we've just defaulted to Badgerfish capabilities. There are other conversion. I didn't want to say standard. I kind of use conventions. There are other conventions. I believe Google has one, Yahoo has one. XML.com has one where they may have things like the text is a # text instead of a $, for example. And they have some slightly different rules, and we built all that in, but like I said, at this point, we're just defaulting everything to Badgerfish and hiding that from you. In general, Badgerfish XML elements become JSON properties. The text element is then a part of an object of that property, which would have a $ key. If you have nested elements, you have nested properties. If you have the same element name in XML at the same nesting level, it becomes essentially one JSON property with an array. Any XML attributes are prefixed with the @ sign, which is also in that JSON object value. Namespaces are in their own XML namespace property where the value is an object, which would contain multiple properties where you'd have a prefix as the key and the value is the URI. If you do have a default namespace that has a property of a $ for the actual, instead of a prefix, you just have the $. And one caveat there is if you do have what I call mixed elements, you have an XML element that, let's say you have an XML element called A that has some kind of text, and then within that text you actually have another child element B. Badgerfish does not handle that well. So that may be one thing that if you do have that, it won't be supported, or it could give you some interesting results. So let's get into some examples. Here's just the policy itself. As I said, initially we had many properties, but we kind of just eliminated all those properties for you to configure at this point, and we've just defaulted them under the covers. The XML must be well formed. There must be a content type that indicates that the data is XML. And assuming that that's the case here, this policy would be executed. Very, very simple, both to configure in the UI as well as in the Swagger itself. There's really nothing but a title and a description. So here are some examples. What happened here? I went all the way to slide 80. Where was I? 56 maybe?
I believe it was, yeah, somewhere in your 50s, yep.
All right, so I guess I clicked to go to the end of the page. There we go. So let me just make sure I didn't skip over. Right. Okay. So similarly, the JSON to XML policy is just a reverse conversion. It does have two properties. We don't guarantee that the JSON, even though it may be following the Badgerfish standards, does have to have a single root element. It could have multiple root elements in the JSON. So because of that, we do require a property which we call the root XML element. It defaults to JSON, so that if you should have more than one root property in the JSON, that we will essentially make the output XML well-formed by outputting this root element. There is a checkbox to always output the root element, so regardless of whether you need it or not, you can check that box and always get the root element if you so desire. But otherwise, again, relatively simple policy to configure on the UI and just the two properties in the YAML. All right, so here's some just simple examples here. I have kind of contrived example here. I have a customer that has name, address, and phone number with all the different parts of their names, in different XML elements. And then you can see, for example, for first name is a property. Customer name and first name, they're all individual properties. John, it turns out to be a text node, so then you've got an object under first name where the key is a $, which designates that will be the text. And of course, John is the text. The other thing that's somewhat interesting here, I kind of threw in a couple nicknames, so John can go by either Bud or Hey You. And so in this case, since I have the same element name at the same level, for nickname you get one JSON property, but then you have an array where the array will contain multiple objects, each with the text of that individual text value. I mean, the same would also hold true if you had objects. So if you had nickname happened to be, or you had some element that happened to be an object level where you had additional subproperties, then the elements would essentially, just be additional objects, just like you saw with customer name and so forth, would be there in the same fashion. Here's a little bit more interesting example, I guess, because it has a SOAP document, so you have XML namespaces. So here in this case, you see that the sub-object has an @XML namespace object, which would have the namespace URI, and the namespace prefix would be the key and the value of those. It also has under, I think it's down in string 1 has this attribute called type. So you'll see that in this case, in addition to the object having a $ for the actual value, you also have the @ type, which would be having the value of the actual attribute value. I also show in string 2 that there happens to be a default namespace there. So you'll see that the $ namespace is also there with the actual URI of the default namespace. One of the things that is kind of inherent in the implementation of Badgerfish is that when you do have a namespace at a higher level, then that is inherited as you go down the tree. And so you'll see that even though the particular elements as you go down the XML tree, if you will, in the JSON output don't necessarily use the particular namespace, that you will be getting those namespaces in the actual output. So what are some things that we were looking to do here? I had kind of mentioned that we had looked at, but kind of ran out of some time here with some of the additional JSON formats, whether it be XML.com, Yahoo, and Google. And so, they have, different characteristics that we chose, at least for this first pass, just to support Badgerfish. So that may be something that we'll be looking at to add in the future. Any comments on or questions on XML, the JSON to XML before I get into map?
Yeah, so one quick thing from, as you were going through your examples, I assume if we have like arrays and things like that set up on the, like if we're going, like if we have arrays, set up on JSON, those would convert automatically to repeating, or recognized as a repeating group set on like on the XML side and vice versa. Is that correct?
Yeah, that's correct.
Okay.
All right, so in this case, if you had my nickname example, should end up producing the same, multiple nicknames as you show in the source here on the left. So the conversion should go either way.
Okay. Any questions on the phone regarding these topics that Steve has covered?
Just one question. On the example you've got at the moment with the SOAP, if we were to round trip this, would we get the XML NS namespaces at each of the levels in the output of the SOAP message? Or does it kind of condense them back up?
It condenses them back up. I mean, technically, the actual XML, if you look at this from the DOM structure in XML, each of those elements would actually inherit from the parent. So it really is not necessary to repeat in the XML SOAP env, for example, on every sub-element. It will inherit that from the parent automatically. So it's not going to be in the actual XML source text.
Okay, so when it serializes it out, if it knows a parent has already declared that, and it's the same, it won't redo it, basically.
That's correct.
That makes sense.
Hey, Steve, in lines 19, 20, 21, 22, over on the right-hand side, XML, or at XMLNS is not a array. Shouldn't it be?
No, that is the standard that Badgerfish uses for namespaces. It's an object that has name value pairs for the prefix and URI.
Okay. Thanks.
And if I was to, sorry, just a follow-up question. If I was to do the JSON to XML, I'm assuming I need to, in effect, generate what's on the right-hand side of these diagrams within a kind of mapping node or something similar.
Yeah, I mean, it depends on how you want to, where your source is coming from, but
I guess what I was imagining is I want to expose an XML service, but it's implemented as a JSON API on my back end already. So I'm kind of doing a XML to JSON and JSON back to XML. But what I'm getting back from my actual service is JSON. And so I'm guessing I would then need to annotate it with the relevant conventions as specified here.
Right.
To get namespaces.
So in your case, the XML names, all the XML namespace and attributes probably don't apply because there's really no understanding of a JSON from a JSON perspective of those XML type of constructs. But when you're talking about just the basic properties and then the actual text values themselves, that would definitely be one approach. When I implemented this, I was trying to go to a broader standard, and so quite frankly, I'd have to go and try it since we've restricted things. That if you just had a very simple JSON that just had property and values instead of using the $sign convention to store the values, I think that still may work. but it's not something that I think we document at this point. So it may be something that you're going to have to try to see if the code would work that way.
If I may just interject here and add my 2 cents on here, the way I see these policies that do the automatic conversion, they're really a convenience, and I don't expect customers would necessarily use them to make an automatic exposure of one, content type to another for that, just out of the box as is. I would expect that, in many of the cases, they want to have much more control over what to expose and how to expose when going from from XML to JSON in many of the cases, or from SOAP to JSON, in which cases you probably would see the map policy being used, or perhaps XSLT policy or gateway script to provide them more control over that. I do expect XML to JSON, the kind of the badgerfish, kind of out of the box, seems to use that more as a convenience if you want to go, quickly from one to the other because you want to operate on JSON only, or because you want to operate on XML only for one reason or another. But I would not expect to bridge, a backend API with let's say a JSON facade just by using these policies. I don't think it would end up in a nice API definition.
And I guess that was just the thing I was trying to understand. It isn't as if you're going to get to a canonical JSON structure where you could just then complete logic as JSON moving forward, because you have a slightly different structure than what you would want to expose as a JSON as well. After going through a XMLs to JSON, I wouldn't expect my standard JSON service to have been to my other consumers who are consuming JSON to be in that format. So I'd probably be writing, unique transformation logic for that anyway. So I was just trying to understand the use case where it would.
No, I would agree with that, right? I don't think we want anyone would expose anything that looks like badgerfish as an XML API, as a JSON API. I think it's in the right money, right? It's a convenience for you to transition from one format to another, and you may want to do that. You may want to use then something like a XLT or gateway script to kind of fine scrub all those rough edges to provide something that's exposable. But you're going to find that when Steve gets to that, the map policy will give you an ability to do that in one jump versus having to do through first a media type conversion, then some other polishing later. You can do that in one jump with the map policy.
Okay, great. Thank you.
Okay, Steve. I think that's it for now. You can go ahead and carry on then. And then if there's other questions, we'll catch those later.
Okay, and this is kind of leading into exactly what William was just saying here. So map effectively is allowing us to do a transformation of one-to-many input documents that may be in one schema to an output document of a potentially completely different schema. And the documents can be either XML or they can be JSON. So this, in a way, is giving exactly what William was talking about, the ability of taking that XML and converting it to a JSON that would match the target environment specific on schemas that you are looking to create. The UI today provides a very nice specification for being able to configure what your inputs and output schemas are going to be. And then with those schemas, it gives you a graphical view that then you can drag and drop from one field on the input side, or many fields on the input side, to fields on the output side, to actually provide what the mapping will be, what those rules will be, and so forth. There is a mapping wire itself that is done by the UI. When it does that, you can actually click on it, and you get a JavaScript expression, which is then evaluated, that will generate the output value of that map as you're combining fields or doing things that could be whatever dynamicism you want to have in your JavaScript. For XML output, the JSV, this is kind of tied in with what Steve Groger was saying earlier. The JSV output is equivalent to the XML schema. It has to be present. I actually gave the link to the Swagger IO specification for the XML object. That gives you the detail for all of those XML tags, which would be where the XML namespaces are specified, what the prefixes would be, if a particular child attribute or child property happens to be an attribute. It would designate a Boolean to say that it's an attribute true. If you have the arrays, then whether the array is wrapped or unwrapped, and if it is wrapped, what the name is, and so forth. Those would all be specified in that schema, and that schema would be required then to generate your XML output. So here's your capabilities here. It's a pretty long list here. You can map just a string literal to some output leaf property. You can map a JavaScript expression to your leaf property. You can actually map leaf input properties to output properties, or input objects to output objects with the same schema, essentially a direct object copy. You can map input objects to perhaps a output object of a different schema. Arrays, you can do a direct array copies. You can do array copies where the elements of the array may have a different schema than what the source input schema was. You can iterate over array properties, and that could produce a scalar output. And then there is multidimensional array support. So you can copy, if your input happens to have a multidimensional array, you can either directly copy it across, or again you can create each portion of the output array, and each portion would then therefore have a potentially different schema. So it's a very powerful capability to do this type of transformation. Some current restrictions that we have right now at runtime. The first output specification is going to be used for the schema processing that must contain a complete output schema document. We use that we iterate through that schema, output schema, to generate, if the schema designates that there are default values, we actually iterate through that, and we create if you will, an initial document based on the schema. And that particular capability then would mean that if you had default values, you wouldn't necessarily, or required values, you wouldn't necessarily have to draw a map wire for that particular map, because it would have been generated for you. You'd only have to generate that if you wanted to override whatever default was specified in the schema. And then we actually iterate through that XML schema to produce the XML output. So at this point, the first output specification, the schema must be there and required. We're looking at modifying that, but that didn't make the cut, at least as far as GA. So the outputs at this point, may be defined for different, what we call subtrees. So we've talked about different context within API Connect of message.body, for example. But you can also specify message.body.customer, for example, message.body.order. That is a capability that you can contain here, but you still have to rely on the first restriction here, that at least the first one has the entire schema, so that the appropriate defaults are generated in the appropriate schema. At this point, scalar outputs to the output root are not supported. So if you wanted to output something, for the example of message.parameter.key, and you wanted to set that to the scalar ABC, what you would do instead is you would set message.parameter to an object which would have key as the key, and then ABC as the property. And then the other restriction for XML is that as far as like named XML elements with different namespaces, that will not be supported. So that is one restriction that you need to bear in mind. So here's the UI. The UI has these pencils here for both the input and the output side. When you click on them, you can define what your inputs will be. The context variable, request.body, you could, if you wanted to actually subtype it, you could say request.body.customer, for example, or request.body.customer.firstname. You could subtype that as deep into the nesting of your document that you wish. It has a name called input. You have to specify what the content type is, if it's JSON or XML. And you get this drop down for the actual definition. So if you are subtyping like that, you could get down to customer first name, for example. That might be a string. If you're dealing with the entire document, at this point the support that is there is an inline schema. And so you would click on that, and the support today is that you actually get a, if you will, an editor where you can either paste a schema in, either in a Swagger YAML format or in a JSON format. So that is the current support. In the future, there'll be capability of specifying files and having a lot of that done automatically for you, but at least for GA, you have to cut and paste the whole schema in directly. So you do this on both the input and the output side to define what your data structures look like on both the input and output side. You can have, as you see the plus input button, you can add many inputs, you could add many outputs, all with different context variable names and perhaps subtypes. Each one would have their own unique name, and then those names would be what are actually referenced on what we call the actual actions, the mapping that you're going to create on the wires themselves. So here's I've defined my kind of contrived sample here. I have an input. I've put in the whole schema for both an input and an output. So I've got my customer data that has my name and address and phone number. I'm generating an output label, so I've got just my full name, address line 1, line 2, and line 3. And you can see that I've actually created wires between each of the input fields. For example, for name, all 4 input fields all map to the full name. So to create an individual map, you actually click on the little circle. I guess I call that the input connection. You click on that, that'll give you the green wire. You can drag that and click on the output connection side. That'll complete the actual wire itself. And then if you click on the completed wire connection, it will pop up a JavaScript template where you can key in any additional JavaScript type of syntax or statements that you would wish to be evaluated to make that map happen the way you'd like it to happen. So we'll just see an example of that. There's a question?
Yeah, sorry, this is Mike. So this is just kind of a cosmetic thing, and this is just the old cast iron guy in me talking. So if you go back to the previous slide, is there any way to make the representations a different color when a function is applied upon it? So for example, it looks like you're doing a concatenation on the full name there. Instead of making it green, just make it make it blue, or just showing that if someone were to pull this map up, they could see where there's direct mapping versus or there's some transformation being applied on that.
Yeah, the UI itself, just by the virtue of the fact that you have 4 individual properties being mapped to one, it generates for you by default a JavaScript statement that is effectively the concatenation of all 4. And we'll see some examples later on the type of JavaScript that you can put in there. But given that just the default map already is a statement of its own, if you were to augment that statement or do whatever you wanted to do in that statement, I don't know how it would know necessarily to paint it in a different color. I could run that by the UI designer to see if there's anything that they could add to say it's custom versus default mapping, if you will.
Yeah,
So,
it's just
that's
kind of just thinking just from a cosmetic thing, but it could just be just the old cast iron guy in me. But yeah, okay, thanks.
okay. So here's some examples. When you click on that output wire endpoint, if you will, you get this pop up, and it's essentially just a little editor. Your JavaScript snippet goes here. So I've just included some snippets here as an example. So by default, you may get something, for example, of customer.address.city plus customer.address.state plus customer.address.zip. Well, that's not very interesting to me because I at least want a space and maybe a comma after the city name and so forth. So I've gone in and modified that to add in a few things to make things look a little prettier. The second example deals with perhaps on that mapping, the first name and the last name are obviously required, but it could very well be that the customer object may not have a middle initial, and it might not have a suffix. I'm not a junior, for example, or anything of that nature. So the end result is that those values in the input source will be undefined, and you don't want just a straight mapping to end up with John undefined Q, John undefined public undefined, right? Because the undefined values will actually output as a string as the text undefined. So in this case, I've written more of a more interesting snippet here, where I'm actually creating a variable which will be returned by this snippet, which is initially set to the first name, and now I'm actually checking for the presence of a middle initial, and I only concatenate my space and their middle initial if that is present. Then concatenate on the last name, and then again, similarly, I will check for the presence of a suffix and only concatenate that suffix, if that suffix happened to evaluate. And then eventually, the last thing here is that the evaluate needs to have a result. So you have to have an expression that is at the end which says what you're going to return. So I just return the variable I've created, and then that will be what will be output as far as the value of that particular evaluation. The other thing that's interesting here is that the UI creates these variable names, if you will, in the JSON by default. Another syntax that is supported is what I call positional syntax. And you'll see some examples of this later, where there's actually a part of the YAML which specifies what specific fields, what specific input properties are being utilized for this particular map. And then you can actually reference them by position in the structure that's provided. So in this case, I'm actually multiplying the first value times the second value, and then there's a special syntax here with $0. There's also a similar syntax of $, with the value of a period, and that's, if you will, I don't want to call it the accumulator. It's kind of like the results of the last action. So if you're iterating over something that's, for example, in an array, you can take some expression on the elements of that array and save it away. In this case, I'm adding it. I think the actual use case that this came from was where I might be multiplying a quantity times a price of each individual array element and adding it to a, if you will, almost like an accumulator. So the end result of this will be the sum total of all the array elements, items times price. We'll see some more examples of that here as we get into more detail. The actual Swagger syntax itself, there's actually two what are called action properties. There is a set and a create. The set is used to set an individual property. The create will be used to create an array. Actions may be embedded within actions. So you could have a set that within the set does additional sets. Set actions. You could have a set that does a create, and a create that does another create, or a create that does a set. So you can go through and create quite complex output data structures based on how you specify your Swagger and the way that these are embedded. At the top level, the action must specify both an input name, well, for the set or the create, you're talking about just output, it must specify the actual output name, and then the specific, path to that specific object within the output. So in our previous example, we had created a output called output. So I might have something like output dot address label dot first name. If we're doing embedded actions, where we're going to be stepping through that, the actual object that you're going to be setting now does not have that actual output name. That's kind of implicit. It's going to only be the object within the parent object that we're actually mapping in this case. So in addition to the actual set and create actions, if you will, there are sibling properties of from, for each, value, and default. So the from is effectively the input name at the top level, as well as then the path to that particular object within that input. Again, if you're doing embedded levels of actions here, then that particular object would not have the input name. That again will be implicit. It's really just the name of the object that's within the from or the for each that we're actually embedded within. The for each is used to specify the actual array elements that you're going to iterate over. The value would be the JavaScript snippets like we showed earlier. They will use either that dollar notation, which would again be either the numeric position within that from array, or it would be the actual from string as well. And then there's a default value that you can specify that should the actual input be either undefined, or if it, let's say you have a JavaScript evaluation that turns out to be an invalid number, whether it be not a number or infinity, that the default value would be used as the output value in that particular case. All right, so this is just more of just kind of a little agenda here on some of the examples that are going to be shown. So let me just step into the next one here. So inputs and outputs. So we showed that in the UI on how you specified that. This is pretty much what the basics of the inputs and outputs will look like. They can be just request.body, as is shown in the lower examples. They can have additional subtyping, so they could say within the request.body, the actual payload that came in, I'd like to just have input 1 be just the customer object within that. I could have input 1A, which would be just the order object within the actual request body. Any of these variables that I think it was probably William that I talked about earlier can be used here. So I could be having a variable on request.headers, request.status. I could have parameters. All the different variables he talked about could be variables that are specified here. As far as schemas are concerned, the schemas can be inlined. So the example in the bottom left shows an inline schema. I just kind of showed the first portions of that, where we have an object where the first property is called purchase order, etc. And then there is an example on the right bottom that shows that there's actually a schema where there's a dollar reference that points to a definition that's somewhere else in the Swagger. And in that case, the schema would be essentially pulled in from that definition. Okay, so simple mapping here. Look at the right side of the screen. I have a very simple scalar mapping. I'm going and I'm setting in the output document something called scalar string, and its value is just a scalar hello world string. So very simple mapping, no input document required. The second example, I'm setting an order date to my output document. And in this case, again, no data that came from the from's data structure. I'm actually using a JavaScript new date and converting that to a GMT string. And so that would be the output of that particular action. The next 4 actions are all equivalent. They're all setting a name. And so you can set a name by just specifying the from. I'm setting the name from input.customer.firstname. The second example is doing the same. It has the same from, but it does specify a value. But in this case, I've specified a positional value of $1, which is the first element, which is essentially the same as I've done before. I can omit the from and specify the value as the UI does, where the actual value is the input.customer.firstname. And I could have a combination of both, in which case it's really kind of a no-op. It doesn't hurt having them in both places. But you could have, for example, examples where you would have froms that would have, the from would have some elements that would be specified in the from, and then you can actually have values that are pulling data in directly by specifying it in a non-positional way. So you can have a combination of the two. You can actually multiply. You can actually use multiple properties to output to a property. So this is more in line with what I had shown earlier based on the UI mapping. So I'm going to set line 1 of my address label. It's going to come from my customer input.number and customer.address.street. And you'll see in this case the from is not necessarily just a scalar as was shown on the upper right, but now in this case it's being specified as array elements. And then the actual value is going to reference those two values. And again, it could have been done as it is shown here. It could have been done positionally with a $1 and a $2 instead of the actual full input names. So here's some object mapping examples. In this case, the output object from the input object is going to be using a different schema. So you'll see, and this is a case where there's actually some embedded actions. I'm going to be setting my shipping details object from my input customer address. And then within that, I've specified additional actions where I'm going to be doing a set of the street from a concatenation of the input data from number and street. So this is a way, if I just wanted to move it straight across, I could have an easy set output details from input shipping details or whatever that's called, and it would just copy the object straight across. But in this case, my output shipping details has a different schema than my input, so I'm dropping into some separate actions to set the specific properties within shipping details, and that's based on the actual data that came in from the customer address object that was read at the primary root level, the root level action. So this is just an example how you can see that the set and the from on the very first part of this start with output and input, but in the embedded actions, the sets and the froms are all dealing with the specific properties within the particular objects that were being either created or pulled from as far as data. And so the same would hold true for city, where we're just uppercasing the city, we're uppercasing the state, and just passing the zip straight across. The second example here is showing a set for a scalar value called order total, and this is going to be using the for each. And the for each is pulling from an item array. And so what this is going to be doing then is from the price and the quantity within the order array, it's going to be multiplying those two together and adding them to this $0 positional property. And then that will allow you to take the price and quantity for each individual item, add them together, and have a complete order total, which is what is going to go into the output document. Here's some array examples. So you just copy a array straight across, whether that array has to be scalar elements or it could have object elements, it doesn't matter. I'm just going to copy from an input array and copy that to the output array. And the output array could be called the same name. It can be called whatever you want it to be. The second example here is going to create an array of objects from an input array where I have a different schema. So in this case, I'm going to be creating a output order entries that's going to come from my input order items. I'm going to iterate over the order items, and then within that I have embedded set actions. So this will be setting the actual object for each input item is going to be setting that. So you see, I'm just going to be calling the actual description here. I'm going to be calling it something else, so it's just going to map that across. My output does not necessarily have a price and quantity. I just have a complete subtotal. And so this is going to be looking at each individual item's price and quantity, just multiplying them together and setting the subtotal of that particular item in the output. And it'll do that for every single input array element, and so you'll get the same number of output array elements, but with different data and different schemas. And then finally here, this last example is just showing an example of actually creating a single scalar called array sum. It's going to, for each over a scalar array, you could have a scalar array, let's just say, has just numbers in it of 1, 2, 3, 4, and 5. And so I'm just going to be looking at each item in that scalar array and adding it to my, in this case, an accumulator value as it goes through that. So the output value in the array I just gave you would give you an output array, an output summary of the summation of 15. That would be the output value in that case. And then finally, just some two-dimensional array support. So two-dimensional arrays, as I indicated earlier, the create is what actually creates the actual output array. So we're going to be creating something called parent array from the actual order items. Within that, I'm going to be creating another array, which I'm calling a child array, that's going to come from an item array. And I'll be for eaching over each of the individual item array elements. And then the actions are going to be to just pretty much just copy this in string to something called out string. And so you get to see these particular output here where I'll have my parent array created. It's going to have, assuming I have n child array or n items in the input, I'm going to create n child array elements within that array, and then within each child array, depending on how many specific items I had within that, I'll create 1 to n out strings for each one of those. So just some kind of basic enhancements, things that we're looking at kind of, dotting the I's and crossing the T's. I saw William in the chat had kind of talked about being able to input a WSDL XSD, having that converted to Swagger for the schemas and so forth. At the runtime side, at this point, message dot, multiple outputs is not something that is supported well at this point. That's something that hopefully we'll get in within relatively quick amount of time, hopefully by one of the upcoming fix packs. And what that would really allow you to do is do if you will, many inputs in to many outputs out. At this point, it's pretty good to do a single multiple inputs in to one output out, but we would have that capability in the future here with this enhancement. And then there's some things of I mentioned there was that restriction on having an output to be a scalar. That is more so tied into things like perhaps header values and that type of thing. But that would be eliminated with that enhancement as well. So I think that is the last of my slides. That's quite a lot for everyone to digest. Questions, I'm sure.
Mike, would it be okay if we do the questions until the very end, and we can stay on just that Shufan has a customer meeting she has to run off to, and we don't get to her now, we're going to lose her.
Yeah, let's do it.
Okay, so Shufan, are you ready? And Steve, will you be able to stay on, Steve, till afterwards so we answer your question? Okay, thank you. Thank
you. Sorry about that.
All right, your slides are up, Shufan. I'll be driving them, so just give me a beep and I'll go through.
Thank you, Nancy. So the portion that I am covering is the OAuth provider. William has mentioned that earlier in the 5.0 release. The API has been broken down into two now. So there is an OAuth provider API that you can create and can further customize it. And the way to do that is, again, through the API. If you drop down on that, there is an option called OAuth 2.0 provider API. After you select that, it will have all this wonderful step-by-step, step you through it, the name of it and what's the base URL and so on. And next slide, please. So I think we will concentrate a little bit more on this one. So if you look at on this slide, on the left-hand corner, you will see two paths. One is, so for people who have worked with the OAuth, there is typically authorization endpoint and token endpoint. As you can tell, there's a default path to that already, is OAuth authorization, OAuth 2 authorization, OAuth 2 token. And if you go to the right-hand side of the slide, this is where you specify, oh, and also I think in 5.0, right, William, it's also going to support multiple scope now. So in here, in the Swagger, you can go ahead do the @ sign in which you can specify what other scopes you want to support. So in this case, I think there's like 2 scopes. One's the insurance, one's the something. I can read my typing here. So there's 2 scopes will be supported, and then the 4 type of grant type this provider will support. And together with the endpoint, this will customize how you want this OAuth provider to work. At the same time, you can also specify the number of refresh token that you want this provider to create it. And at the very top of the slide, you will see something called client type. This is also, you can specify whether this provider only supports public grant type or the confidential grant type. Next slide, please. So for people who love, okay, so Aussie earlier has talked about the security definitions. So in here, you can see a little bit of what it looks like. So on the top is where you define the security, and the one in the middle is how you use the security. So you have to define the security and then how you're going to use it in the security section of it. And for people who like to get down on VI or looking at the code itself, you can click on the source. So if you click on the source, what I would like to call out is there is a template which is created, very nicely done. In there, that will give you a pointer for a given grant type, what kind of information is required for each one of those. So you can click on the source and look at the YAML directly from the source view. Next slide. So how did all this pull together? So now when you host an API, which is going to be protected by the OAuth provider, you define an API. So in this case, I'm just defining an API. And within the view, in the security view of the API, this is where you can define you want to click on the plus sign, and then you can say, I want to protect this with OAuth. And the session in here, like the authorization URL, this is like information only. So for people who are using this API, which is protected by OAuth, they need to know which authorization URL has to be. An online document will tell you how you have to build this, because you need the catalog information in there and you have the organization information in there. That is how the whole URL looks like. And within here, the scope part is the interesting part. So for customers who need to who run this API, which is protected by OAuth, for them to be able to use this API, the token itself, which is generated by the OAuth provider, need to have the right scope. So what this is saying, for you to execute this API, you need to have this /insurance scope in order for you to use this. So this is how you define the whole API generation. Again, you can do all this manually with clicking on the source view. Next slide. Okay, so let me see, what am I trying to say here? This is how you put the whole thing together. So once you create the API, you have the OAuth provider and also have the API itself. You package that into a product. So in here, if you can see that we're packaging this, you have the OAuth provider, which we created earlier, and also you have the API itself also packaging together. So you can push this in a catalog and publishing it to be used. Next slide.
This is your last slide.
So I quickly go over this, but I have to tell you, all the great work, William has done amazingly good work with us. So if you have any questions, we can always wait to the end to talk about those.
So I think we should, pause and have a quick Q&A session here. So any questions for Shufun before she goes off to do her customer meeting?
Going twice. So
One thing at this point we don't necessarily support third-party OAuth providers yet. Is that correct?
Yeah, absolutely correct. At this point, we don't support third-party OAuth provider at this point. However, if you are talking about the ISAM integration, OSER has done a custom policy. So if you need more information about that, just reach out to me on the side.
Okay.
So there is some custom policy. We have some material that can be used with us.
Well, I know Ozair is on vacation this week, but do you know if that's going to be like a GitHub shareable kind of type of resource, or?
I think it's already shared on the Git, but I'm not sure whether he put that in the public site or not.
Okay.
Yeah.
All right. Yeah, I'll follow up with Ozair to find that out, because that's something I think we should get out to the field.
Yep, absolutely. So I think there is some material that can be used. The fun part of the whole exercise is consolidate the client information, right? Because the ISAM need to be able to know the same client information as the API management.
Mm-hmm.
Yeah. So other than that, I think the custom policy, we have proven that it does work, working with the ISAM pieces. So to work with ISAM, that would be the right way of doing it at this point.
Yeah, there's a customer in South America that's already using ISAM with API management. So, so we definitely know it works. Okay.
Yep.
Any other questions for Shufan?
No. So there's a question about Joe. In this case, for the scope information, we literally just do a string comparison. So it doesn't really do the path, looking for the path. All set?
Okay. Thanks, Shufan.
Thank you. Bye.
Ramon, I see your slides.
Okay, so I'll be giving a brief overview of set variable, the set variable policy. It's basically a policy that is used almost everywhere whenever we need to store information for data retrieval and use. So as you can see here, it's used to maintain variables on the flow, aka runtime variables. On data power, they're stored in a data power context, and this causes a little bit of discrepancy between the micro gateway and the data power version of set variable, but for the most part, they're very compatible. There are two types of variables. The user variables, these are variables basically that have no special meaning. So in William's presentation, he had the set of context variables, request.star. Those would be considered special. So those get special treatment. The user variables, if you just try to come up with a name, foobar, those get stored in a context by that name. There's no special handling on them. So set variable has three functions called actions. There's set, you give it a name and a value, and it assigns that value to that name. There's add, and it basically adds to an existing variable. This is the part where the micro gateway and the data power implementation differ. Add on data power is mainly focused on headers, so you can add the headers that are already there. For anything else, it kind of does a stupid concatenation. It's something we plan on working on in a fixed pack to see if we can get closer to the micro gateway implementation, because it's a bit smarter. And then clear is simply just basically deletes the variable. Okay, so I guess I already went over this slide. And the user variables, again, no special meaning. They're basically just a data power variable. And then the special variables, the one that's very interesting is message. So message.body represents the current data that's on the flow. So if you use set variable to set the message body to some content, and then do an invoke, for instance, the backend will get whatever you just put it in message.body with set variable. Headers is also a special one. It affects the headers on the wire. It's not stored anywhere. As soon as you do a set variable on message.headers.header name, it's on the wire, so it's ready to go out. And status is only applicable on the response. So on the response flow, you can do a message.status.code or .response, and that will be the status code and response that the client receives. They can be set separately, or you can set a string that has the code and the response. Request.body and request.headers and all the others that William noted, they should be considered mutable. You can read from them, but you should never set them. And here's an example. If you were to use the UI or type directly into the source view, the Swagger, it's very simple. It takes two parameters, set and value. Set is where you would put the name of the variable, and value is the value. And here you can see I'm using the $sign parentheses notation. That basically allows you to reference another already existing variable. So in this case, message.header, my header, would have the value that's in incoming header. Okay? And there's also a custom policy implementation available in API m.custom that allows you to do this in your custom policy. It's the same behavior all the way through. And that's all I have for you today.
All right, thank you, Ramon. I guess we can do the Q&A now. Those are still on. Thanks for staying on.
Yep. If you have questions, star 1 to take yourself off, and then, yep. So fire away. Anyone? Okay. With that, I think then, if that's it for this session, we will have another session after this one at the top of the hour. I will be closing this meeting, and to get the recording, all that. So you'll all need to dial back in then. But I just want to thank Ozzy and team for coming on and presenting. A lot of good information. Thank you very much.
Yep. Thank you, guys.
All right.
Thank you.
Thanks, everybody. Cheers.
Cheers. Bye.
Yep.